let's look at the overall aim of you studying this paper. That is to develop an understanding of the mathematical principles and concepts which are useful in problem solving and decision making. Then, what should be expected of you? So as you go for an exam, so for any quantitative techniques paper, what do examiners expect from you? So in the first case, the examination is set of course to test whether the student can demonstrate an understanding of statistical methods used in decision making. So there are many statistical methods which you learn in this paper. And then next, to demonstrate an understanding and application of statistical and mathematical models for estimation and forecasting. So you look at that, we shall look at that later. Then demonstrating an understanding and application of techniques used in solving optimizational problems in management. So here we have a syllabus summary. Some people, they study the subject, they read without even putting regard to what the syllabus is all about. So you find you are reading things which are irrelevant. So I have the syllabus summary. We shall go through this very, very fast. So I have the introductory part. You have to understand the meaning of statistics, functions and limitations of statistics, types of statistics, descriptive, inference statistics, then statistical data, presentation and measures, distinguishing between primary and secondary data, sample and population. Those terms, they can be examinable. Sources of data, methods of data collection. So those are the theoretical areas in the syllabus. Methods of data presentation, measures, for example, measures of location, measures of central tendency, measures of dispersions, and then probability and distributions. So probability theory, permutations and combinations. Then we have estimation and hypothesis testing. So here you need to be well versed with getting confidence limits, confidence intervals, control charts, then index numbers, meaning, uses and importance, limitations of index numbers, then types of index numbers, simple and weighted, both price and quantity indices. Then we'll have regression and correlation. So methods of computing for the correlation coefficient. Then use of regression line. Then we'll have time series and forecasting. So all that at least you need to cover before you go for an exam. So have linear algebra and calculus. So here you have to learn about differential equations. So methods of solving quadratic equations, formulating equations, then functions and graphs. The basic rule of differentiation, chain rule, then the quotient rule. So this is a summary of the syllabus. Of course, there are some other areas which are not included here. You need to read or you study based on what is indicated in the syllabus. So decision theory here, types of decision making, computation of expected values, and then we have the other section, that's linear programming. So assumptions applied in linear programming, advantages, limitations. So methods of solving linear programming problems, graphical method, simplex. So those areas you need at least to focus on them. Then network analysis. So definition of the terms, drawing networks, then determination of earliest start time and latest start time. So that is in brief the syllabus. I've just gone through that. Of course, you have to look at your syllabus book and you look at whether those areas are covered. So always talk about the relevance of the subject in the day-to-day life. Because as you study these mathematical principles, they are not ending there. We need to look at how we can apply them in the day-to-day life. So how can we apply the mathematical principles in the profession? So that is important, and we always stress that. You know, some students, they learn, they just want to study, then they pass, and they leave everything there. They don't think about application. So we are saying the relevance of quantitative techniques include but not limited to the following. So the first case we have this one, helping in report writing. So paper 18, of course, you require to, most cases you find examining somebody to write a report. So when you are writing a good report, you may not put, of course, you need to have summaries made in the report. Then here we are saying to keep the main body of the report short enough to hold the reader's interest. Detailed explanations are put in appendices, and then we have them made to cross reference with the main body. So here data is presented. Of course, we talked about the data presentation techniques. So we present data using a pie chart. You can use a bar graph, you can use a line graph, you can use a histogram. So those are some of the techniques we can use to present data. So this always conveys the message in a way which the audience can quickly understand. Then we have with auditing, we can use these principles in oddity sampling. The auditor cannot apply the audit procedures to 100% of the transactions. If, for example, an entity has had 1,000 transactions in a period, you may not be in position to audit each and everything. So you have to come up with a sample which is going to represent the population, that is those transactions. So here you learn about sampling techniques. So you can, of course, use an appropriate sampling technique to select out a sample which represents the characteristics of the population. Of course, that knowledge is taught here in paper 2. Then we are saying the reliability of the results of the sample, of course, depends on the size of the sample. If you select a sample which doesn't represent the population, you end up making wrong conclusions. So we have quantitative techniques helping us in doing oddity sampling. Then we are saying the sufficiency of oddity evidence, of course, is related to the design and size of the oddity sample, among other factors. So some of the sampling techniques, we have random sampling, stratified random sampling. You can use systematic sampling, multi-stage sampling. These are some of the sampling techniques which somebody can use. Then we have this subject helping us in forecasting. So trying to come up with figures which, for example, can put in our budgets. So historic data, we say, can be used to determine the direction of future trend. For example, future demand for an entity's goods and services, future costs that may be incurred, and many other factors. So we say this makes it possible to estimate figures which you can include in budgets or which you can include in prospective financial statements. Some of the forecasting techniques which we can use, we have linear regression analysis or least squares method, moving averages, exponential smoothing, and some others. So, for example, somebody can use linear regression analysis in forecasting. Here you determine the line of best fit, and then you can be in position to extrapolate, for example, how much that can be incurred within some 6 months to come, but using past data. But of course, when we're using linear regression analysis, that's the linear regression equation, y prime equaling to a plus bx. You have to be, because some of these equations, they are given in the question. So you find them at the back of the question paper. So you need to learn how to use these equations. So where we have a that is representing the fixed component, then we have the variable factor component represented by B. So here, when you are doing the forecasting, you need to identify the dependent and independent variables. So what depends on the other? For example, when you are forecasting costs to be incurred, so costs depend, for example, on their level of output. So output is an independent variable, then costs become a dependent variable. Sometimes in the exam, somebody may not specify to you which is which, and you have to, of course, figure out the way of identifying these variables. You need to judge which is depending on the other, so as to avoid confusing values of x for y. So you input in the formula, then you come up with a linear regression equation, which you can use to forecast any given variable that is examined. So we have, for example, we are saying you have to note that the line of best fit that is derived represents the regression of y upon x, but as well can have the regression of x upon y. So given by that formula, so you should not confuse those two. So we use different equations. So when you are using linear regression analysis, of course, you need to know the relationship between the two variables under consideration. So in practice, before you apply that equation, you need to first of all establish whether there is a relationship between the two variables. Otherwise, you can come up with again wrong conclusions. So it's saying that it should be also noted that if there is a causal explanation for correlation, does not follow that variations in the value of one variable cause variation in the value of the other. For example, sale of ice cream and sunglasses, they are well correlated, not because of a direct causal link, but because of the weather, the season. So, of course, you don't need to follow the model blindly. You need to also look at other factors. Then also use the subject in making optimal decisions. So, for example, you can use the linear programming model in determining the optimal allocation of resources, like materials, manpower, machines, in the way that minimizes costs or maximizes profit. So, for example, the financial manager of an insurance company, bank, can use the linear programming model to select the investment portfolio of shares, bonds, and other assets, so as to minimize the farmer's return on investment. So you look at the combination which can yield the maximum profit. So the risk of the returns from an asset is measured as the variability of returns, rates of returns. So look at different investments. How are the returns varying? For example, if the company made profits of 2 billion by the end of last year, then by the end of this year, it makes a profit of 500 millions. Then the other year, it makes a profit of 3 billion. So have returns keeping on fluctuating like that. So you first begin by calculating the average rate of return. The formula is shown there. So have that estimator. So you get the mean, that's denoted by R bar. Then you calculate the deviations of individual rates of returns from the average rate of return. That's the procedure of computing for standard deviation. Then you calculate the sum of the squares of the deviations as determined in the preceding step. Divide it by the number of periods of observations. Then you less want to get the variance. So in case of a sample of observations, we can divide the sum of the squares of the deviations by the number of deviations minus 1 to account for the degree of freedom. If population data is used, then the divider is n, the number of observations. Then you calculate the square root of the variance to determine the standard deviation. So that is the formula. So I have the question there. The name of the company was named Pine Manufacturing Company. It makes 2 types of flavors, HB and DH. So the profit estimates, they are given for each product, 25 shillings, and that is earned from HB, 30 shillings from DH sold. The labor hour requirements in each of the company's production departments, we have them summarized below. So you can just pick out the most important information, summarize the question. Of course, you have the solution there, but you need to have the question with you. Then there is some other information. The production supervisors in the departments have estimated that the following number of labor hours will be available during the next month. So Department A, 450, Department B, 350, and Department C, 50 hours. And then the company's objective is to maximize profit. So that is the scenario. Then, of course, they have given us the level of availability of this resource, that's labor hours. Then what is required? So we need to formulate a linear programming model for the above problem. That will be part A. Then using a simplex method, determining the optimal solution and the profit. Then you identify the department with slack time. So here, among the 3 departments, you need to identify which one has unutilized time, which one has some spare capacity. So that is the question. So relating the number of units of HB, B denoted by B, number of units of DH by N. So that is could be the answer to part A. So our objective is to maximize profit, denoted by Z. Then we are multiplying the number of units of HB, that is B, by the profit per unit, and even that is 25 times the number of units made by B, made for B, the number of units made, that's for product N, multiplied by 30, that is the profit per unit from that product, that flavor, that is DH. So these are the constraints. So when multiplied by the number of labor hours in department A, which are needed to make a B, plus the number of labor hours in department B needed to make a unit of N, they should not be more than 450 hours, equal or less than 450 hours. So that is what is available. The same is done for other constraints. So have the non-negativity constraint, B, N can never be a negative. So they are greater than 0. So when you get a negative number of units, you know you have failed the question. So that's the meaning of the non-negativity constraint. So I'm moving on to the simplex model. We have Z equaling to that. Of course, we introduce these slack variables to represent the unutilized amount of the scarce resource, which is labor hours. So here, the number of S's which you use, because somebody can ask, how can I determine that I'm ending at S3 or at S4? So of course you look at the number of constraints that you have come up with. If there are 5, you can have up to S5. If there are 6, you can have up to S6. Yeah, it doesn't matter. So we have the objective function. So you come up with this standard linear programming model, and then you form some kind of a matrix. So we have the initial table looking like that. You just pick the coefficients and then put them in the table. So we have the basic variable, decision variable, those are the products. And then you have the slack variables representing the unutilized resource. Then the solution values. So just pick for the first constraint, we will have that 1.53, then we'll have 100, like that. Then for the second one, we'll have the coefficients picked and put them there. The third one, like that. If we had the fourth one, then we'll be having 0, 0, 0, 1. So let's look at the initial, the first table. So here we are going to look at how can we come up with an optimal solution. How can we calculate? Because that's what is sometimes disturbing. So how can you determine the values? Then how do you arrive at the optimal solution? So we have the first table. We have the Z0, which is the objective function being represented there, 25, 30, 00. Then in the Z0, the value, the greatest value, greater value will be determining what we call the pivot column. So the 2 under the decision variables column will have 30. Therefore, that is our pivot column. Then from there, we can divide the values in the solution values column by each of the values in the pivot column. So we start with the 50. Also with the 0 divided by 30, well, that is 0. Then we have 50 divided by 0.25, we'll have 200. 350 divided by 1, we'll have 350. 450 divided by 3, we'll have 150. So having divided the row with the lowest value is taken as the pivot row. Then the intersection of the pivot column and pivot row is the pivot element. I wonder whether you can see where those two columns intersect. Yeah, so the point of intersection is at 3. Through the pivot column, the point of intersection is 3. So that is what we are calling the pivot element. So if you are to prepare the next iteration table, you have to divide each of the values in the pivot row by the pivot element. So we shall be dividing the pivot row, that is beginning from 1.5, then 3, 1, 0, 0, and then 450. Then we divide 1.5 by 3, then 3 by 3, that's a 1, 1 by 3. So that one applies to the entire row. So that is what is, that's how the table now will change. Then when we reach there, we will have to make sure that all the values in the pivot column, we change them to 0. So you try to think of a formula which you can apply to change the values in the pivot column to 0, except the pivot element. So now in this case, the pivot element is 1. Then you think of how you can reduce these values to 0. Because how can we test for optimality? So when you discover that you have, that is the Z row and decision variables column, you have all the values there turning to a 0 or to a negative, then that is the optimal solution. Then you can start interpreting the final table. So have table 3, which involves reducing the values in the pivot column to 0. So that's how, for me, that's how I did it. But it doesn't mean that all of you have to do the question the way I did it. You have to think of the formula which you can come up, because here we are using a row reduction to reduce the values in the pivot column to 0, except the pivot element. So we'll have, for example, in the second row, because we had the pivot element being in the first row, as you can see, row 1, that one we don't change it to 0, we leave it as it is. Then how can we make, we can go back to, so when you look at table 2, we have in the second row, we have 1. How can we make 1 a 0? Using a row reduction. How can we make a 0.25 a 0? And then how can we make a 30 turn out to be a 0? So those are the equations which are there. So table 3. So to make the other one a 0, we are using row 2 minus row 1. As simple as that. 1 minus 1, then we'll end up with what? With a 0. So if we have that formula, row 2 minus row 1, that formula will apply to the entire row. So we shall be having row 2, then figures in the second row, then we subtract there figures in the first what? In the first row. Then the next row, the third row. So we can first go back to table 2 and you see that value. So how can we make a 0.25 become a 0? Then we have, so I've used which formula? So you are going to look at that. That is 0.25 times z. So 0.25, then we have this minus 0.25, there's some mistake there, times the row 1. In row 1 we had a 1, so this one would have been 0.25 minus 0.25 times row 1. That's 0.25 minus 0.25. Then we have what? A 0. So you can look at that. Then the formula applies to the entire what? To the entire row. So the figures change. Then how can we make a 30 become a 0? We have the Z row. That is where we have a 30 minus a 30 times the row 1 here. In row 1 we had a 1. So we have 30 minus what? Minus 30. Then we end up with a 0. And then that one applies to the entire row. So remember, in the decision variables column, under that column for product B, we had a 25. So if you apply that formula, we have 30. Of course, that is 25. What is in the Z row? Then minus 30 times 1. So that one becomes, so you can first check. So had the 25, then minus 30 minus C, I mean the times the R1. So that one becomes which value? So we are having the 10 here, that is Z. Now, when you look at the 2, we have 0 here, then we have the other figure becoming a 10. So we have to select now the new pivot column. So the greater value in the Z row now becomes our new pivot, determines our new pivot column. So from there we can identify the pivot row. So when you look at the solution values, so the one which is of course the one which is the smallest will be determining the pivot row. So we get the pivot element and we repeat the same process. So have the same process repeated. You change all the values in the pivot column to 0 until when you see that the values in the Z row, but concerning the decision variables column, they have turned it to be 0. So at this level, that's the work which is expected from you. So we'll go to table 4. So how do we arrive at these values? Because we had changed all this to 0. Then, of course, we had 12.5 being our pivot row. Then we have all the values in the pivot row divided by the pivot element, the intersection of the pivot column and the pivot what? Pivot row. Then we have those values also changing. And then the final table. So you go step by step until you arrive at the optimal solution. So the final table, of course, we have to reduce the other figures in table 4, pivot column to 0. So we're applying those equations, row 1 minus 0.5, row 3, then you get a 0. Then that formula applies to the entire row, like that. Then row 2, then we have row 2 minus 1.5, row 3. We have the formula applying to the entire row. So here, the biggest task is to think of which formula that you can use. That is using row reduction to reduce the values in the pivot column to a 0. And that is with the last row, we have row 2 minus 10, row 3. So we can apply that formula to the entire figures in the entire row until when we get now we have arrived at the optimal solution. But how can we interpret this? That one becomes a challenge to some students. So with interpretation, We have the results here in the solution values column. So we first look at the slack variables, but focus on the Z row. For S1 we have negative 3.33, S2 will have 0, S3 will have negative 80. So for the slack variables, where you see that there is a 0, then that implies some spare capacity. It implies an unutilized resource. And when you look at the way we are arranging our work, S1 was representing Department A, S2 Department B hours, then S3 Department C. So here we are having a 0 with S2. Then in that order, when you look at the rows, we had the first row, the second row, third row, representing those constraints. So for Department A, where you have N, that was the constraint for Department A. Department B, that is where we're having S2. So the value of this unutilized resource, we can read it off from this column where we see S2. In the solution values column, we have 50. So those are the number of labor hours that are not utilized. That is for Department B, labor hours. So when you are through with that, so with these other ones where you see negative 3.3, negative 80, that one we can use it to determine the shadow prices, the price that we pay for an extra unit of the scarce resource. And it can be also examined. You can ask you to, somebody can ask you to determine the shadow price for Department A hours, shadow price for Department C hours. So to obtain one more hour in Department A, you have to pay something in excess, that is by 3.3 shillings. Then for Department C, you pay 80. So this is the contribution of an hour in Department A that is made to the overall profit. So when you introduce one more hour in Department A, that means the profit is going to increase by that much. So if you are trying to maybe source for an hour in Department A, you should not pay more than what you are going to earn as your profit. So you shouldn't exceed that limit. Then, having identified the unutilized resources, the other values in the solution values column, they are giving us the optimal solution. How many or how much of product B can be made to maximize profit, how much of product N that can be made to maximize profit. So here we can say that for product N, we need to make 100 units. Then for product B, we also make 100 units in order to earn a maximum profit of 5,500 shillings. So we've observed that the optimal solution is produce 100 units of HB, 100 units of DH. Then maximum profit from the above production mix is 500 shillings. Then we had to identify the department with the unutilized time, and that was Department B. It had 50 hours not utilized. So in brief, that's how we can go about that question. So what are some of the causes of student failure of the examination as reported by examiners? So we are going to look at some of these causes that make students fail their examination. So the first is we are looking at failure to use the formula and tables provided at the end of the question paper. So that one leads to loss of easy marks. You find somebody has been given a formula but cannot use it. When he writes the formula, he writes it in the wrong way, yet it is given in the question paper. So those are some of the careless mistakes people are making. Then failure to identify the basic concepts or terms used in each question. So at the end, the student ends up failing to answer the question as required because he did not take a note of the key concepts that are used in the scenario. Then neglecting the use of scientific calculators in computational work. So somebody can even think that he's going to use his phone in the exam. So reaching there, they say, you leave the phone here, and somebody tries to maneuver with his head. Yeah. So if you're trying to, for example, you're trying to look for the combination or permutation using a head, I don't know whether you can manage to do that. Then, so have some others like premature approximations. So these lead to loss of the degree of accuracy, and this leads to the candidate's failure to score full marks. So when you are rounding off, it is advisable to adopt at least 4 decimal places, unless it is stated otherwise in the question. You have to focus on the theoretical part. You find somebody cannot even define some simple definitions. For example, they say distinguish between population and a sample. Yeah, define a point estimator. So such definitions, they can you can at least score some marks there if you put attention to them. Then failure to carefully read and internalize the questions so as to apply the correct method. So some candidates fail to adhere to particular methods demanded in the question, and they end up using alternative methods. So that can lead to loss of marks. For example, if the question is requiring somebody to determine the optimal solution, the dual and the primal. So of course, here when we talk about the primal, if you have a maximization problem, then it's a minimization problem becomes the primal. Yeah, so that is what is done here. So just turn the minimization problem, a maximization to a minimization problem. And of course, when you are doing this on the graph, you may find it is somehow different. You get the solution. What has been the maximization turns out to be phrased as a minimization problem. Yeah. So I don't think we can have time to go into details of computations to see how we can have a dual change to a primal. Yeah, but of course, that is what it's about. And somebody has talked about simplified books. I think Madame Deborah will tell us about that. ISPAO has some study packs which you can supplement to these books. I think they are somehow simplified. Then this one being a mathematical paper, you can also use because some students didn't offer math at A level. There are some textbooks at A level textbooks which you can use to understand these mathematical principles properly, because some of them they feed into that work which is taught at what? At A level. Though this one it's somehow broader, because now when you look at linear programming, you look at it from a broader perspective. But to have the foundation, there are some books. I don't because we have others, understanding pure math by Thandler, that is Sutherland, D.W.S. Thorney. It's a very good book. If, for example, you're not getting how to go about to differential equations, so the book simplifies that work. So those are A-level textbooks, but they can also help you at this level if you don't have the foundation in mathematics. Then somebody has talked about, was asked a question where I picked this question. This question is not a past paper question.